Imagine waking up every morning to the same sky. The sun hanging in the exact same position. Not rising, not setting, just frozen there. If you live on the day side, it never gets dark. That star burns overhead, relentless, eternal. If you live on the night side, it's always cold, always dark. The stars wheel above you, but your sun never appears. This is what it means to live on a tidally locked planet, and it might be the most common type of world in the galaxy. Tidal locking happens when a planet's rotation becomes synchronized with its orbit. One side of the planet always faces the star, the other side always faces away. It's the same reason we only ever see one side of the moon from Earth. The moon is tidally locked to us. Its rotation period matches its orbital period, so the same face is always pointed toward Earth. For planets, this happens most often around red dwarf stars. Red dwarfs are small, dim, and incredibly long-lived. They make up about 70% of all stars in the galaxy. But because they're so dim, their habitable zones are close, very close. A planet has to orbit near the star to receive enough warmth for liquid water. And when a planet orbits that close, the star's gravity pulls on it unevenly. Over millions of years, this tidal force slows the planet's rotation until it stops spinning relative to the star. One side locked in eternal day, the other locked in eternal night. Let's start with the day side. Imagine standing there. The star hangs directly above you. It never moves. The heat is constant, unrelenting. If the planet is too close, the surface temperature could reach hundreds of degrees. Water would boil away, rocks would soften. The atmosphere, if there is one, would be blasted by stellar winds. On extreme tidally locked worlds, the day side might be an ocean of lava. Molten rock flowing across the surface. No life, no shelter, no escape. But not all tidally locked planets are this extreme. If the planet has a thick atmosphere, heat can be redistributed. Winds carry warmth from the day side to the night side. This could stabilize temperatures across the planet, making the day side hot but not unbearable. Now, the night side. You stand there, and the star is gone, hidden forever behind the curve of the world. The only light comes from distant stars, and maybe the faint glow of the day side's atmosphere, refracted around the planet's edge. The temperature plummets. Without sunlight, everything freezes, water turns to ice. The atmosphere condenses and falls as snow. On some tidally locked worlds, the night side could be so cold that even the air freezes solid. Layers of frozen nitrogen and oxygen coating the ground. The planet's entire atmosphere migrating to the night side and just staying there, leaving the day side airless. Between these two extremes lies a narrow band. The twilight zone, not the TV show. This is the Terminator line. The region between eternal day and eternal night, where the star sits forever on the horizon. This is the only place on a tidally locked planet where conditions might be survivable. The temperature is moderate, not too hot, not too cold. The light is dim but constant, a permanent sunset, stretching around the entire circumference of the world. If life exists on tidally locked planets, it would be here. In the twilight zone, imagine the ecosystems that could evolve. Plants that never experience full sunlight, adapted to the dim, reddish glow of a red dwarf star. Their leaves might be black, to absorb every single photon they can. Animals that live in the boundary between light and dark, migrating along the Terminator as conditions shift. Never venturing too far into the scorching day or the frozen night. And what about intelligent life? If a civilization arose in the twilight zone, Their entire culture would be shaped by this narrow strip of habitability. They would see the day side as a land of fire, the night side as a land of death. Their myths would speak of balance, of living on the edge between two hells. They would never experience a sunrise or a sunset as we know it. The star would always be in the same place. Time wouldn't be measured by the sun's movement, but by the stars wheeling overhead, or by the cycles of their own biology. Their concept of direction would be different too. Not north, south, east, west, but toward the light, toward the dark, along the edge. Now, there's a real tidally locked planet we've discovered. Proxima Centauri b, the closest exoplanet to Earth, only 4 light-years away. It orbits Proxima Centauri, a red dwarf star, and it is almost certainly tidally locked. Proxima b is roughly the same mass as Earth, and it orbits in the habitable zone of its star, but that star is violent. Proxima Centauri regularly unleashes powerful solar flares, blasting the planet with radiation. If Proxima b has an atmosphere, it's constantly being stripped away. If life exists there, it would need to be deep underground, sheltered from the radiation, living in caves or subsurface oceans, never seeing the sky. Another possibility is that tidally locked planets could have extreme weather. If the atmosphere is thick enough, winds would roar from the day side to the night side, carrying heat and redistributing energy. This could create permanent storm systems along the Terminator, hurricanes that never end, lightning that never stops. A planet where the weather is always catastrophic. And yet, life might adapt. Life is resilient. On Earth, we find organisms in boiling hot springs and frozen Antarctic lakes, in acidic rivers and deep ocean trenches. Life doesn't need comfort. It just needs energy and liquid water. Tidally locked planets could provide both, at least in the twilight zone. But there is a darker possibility. What if a tidally locked planet loses its atmosphere entirely? The day side becomes an airless oven, the night side a frozen vacuum, and the twilight zone, a thin line where ice sublimates directly into space on one side and condenses back into frost on the other. A world slowly bleeding its atmosphere into the void until nothing is left. Just a dead rock, half scorched, half frozen, orbiting a star that will outlive the universe. These planets remind us that habitability is fragile. Earth spins. We have day and night, seasons, weather, a magnetic field, a stable star. We take these things for granted. But in the galaxy, we are the exception. Tidally locked planets are the rule. And if life is out there, it's probably living in twilight, on the edge of fire and ice, in a place where the sun never rises and never sets. Thank you for watching. If you enjoyed this journey to the edge of habitability, don't forget to like, subscribe, and hit that notification bell for more explorations into the cosmos. Until next time, keep looking up.